Let's get right into it. Today we're unpacking a truly radical 2026 paper by Dean A. Kulik titled The Half-Offset Carrier. For over a century and a half, the Riemann hypothesis has basically been the holy grail of pure mathematics. But Kulik's framework does something absolutely unthinkable. It stops trying to solve it with traditional number theory. Instead, it reframes this ancient math problem into strict software engineering. We're going to look at prime numbers not as static objects sitting on a graph, but as actively executing code. Kulik's core argument completely shatters how we historically view this. He argues that the Riemann hypothesis is actually a runtime safety property of a coupled arithmetic analytic system. Traditionally, we've always treated the zeros of the zeta function as mere coordinates, right? Just places to find. But here, an offline zero isn't just a point on a map. No, it's an illegal state. It is literally a fatal software crash in the operational geometry of reality itself. So here's our roadmap for today. 1. RH as runtime safety. 2. The universal involution mold. 3. UATS, the 7-tuple. 4. The separation energy lemma. 5. The nexus RH operator architecture. And finally, 6. A universal structural law. All right, moving into section 1. RH as runtime safety. Let's see how a purely existential conjecture turns into a strict compilation problem. Okay, let's dive into the critical line of the Riemann zeta function, where the real part of S equals exactly 1/2. Now, traditionally, this is just the imaginary line, where all those non-trivial zeros happen to accumulate. But Kulik redefines this entirely. The critical line is not just a location, it's the fixed point seam of an involution symmetry. Think of it like a flawless mirror inside the system. The prime stream can only cleanly evaluate to 0 when it's exactly on this mirror. To really get why, we have to break down the prime factors. Every single factor decomposes into 3 channels. You've got the carrier weight at that 1/2 seam, the vertical phase, which is pure circular motion, and the lateral drift, which is represented by alpha. And here is the absolutely crucial point. On the critical line, alpha is 0. There's 0 lateral drift. But if you step off that line, lateral drift contaminates the stream. It creates a lateral wobble. Actually, scratch that, it's more like a spinning top completely losing its balance and flying off the table. A 0 occurring there would mean the system somehow survived a lethal wobble, which totally violates the strict closure rules of the universe. Which brings us perfectly to section 2, the universal involution mold. At the very heart of this geometric engine is something called the seam. The paper defines it as the invariant boundary, an unoccupiable locus of pure constraint, where opposing pressures achieve perfect equilibrium. So basically, it's a structural anchor. Any system that is a perfect folding symmetry is forced by this anchor to split its state space strictly into 2 orthogonal channels. The first of these 2 channels is the exhaust, or the E channel. In plain terms, this is that lateral drift we just talked about. It's an illegal state. It's a dangerous wobble that completely fails the runtime safety check. And because of the symmetry of the seam, this exhaust must be entirely annihilated for the system to successfully execute. It has to vanish. In direct contrast to that, we have the residue, or the R channel. This is the preserved vertical phase. When the geometric mold clamps down and crushes the exhaust out of existence, the residue is what actually survives. It's the pure observable output of the system. Now, this brilliantly illustrates that this isn't just some clever math trick. No, it's a universal law operating across all scales. Look at mechanics. The medieval Tusi couple perfectly cancels vertical exhaust to leave a residue of linear motion. Jump to digital systems, and the BBP formula for pi annihilates logarithmic endpoints to output pure arctangent phase. Cryptography uses it in SA256 hashing. Machine learning literally relies on it to cancel drift in transformers. Even biology follows this mold. DNA utilizes a template strand as the exhaust and a coding strand as the preserved residue. It's everywhere, right? Let's move straight into section 3, UATs, the 7-tuple. UATS stands for the Universal Action Type System. It's a 7-tuple signature calculus that extracts the operational geometry of any symmetric system. Think of it as the ultimate diagnostic toolkit for the universe. We have S for the symmetry operator, A for the active aperture, and K for the exactness kernel. Then we have our 2 outputs we just covered, the E exhaust and R residue channels. Finally, you have the environment itself, B for the geometric base scale, and C the closure rule that definitively proves the exhaust has been annihilated. And what's truly fascinating here is how even the most foundational math we know maps perfectly to this typed calculus of exhaust and residue. Take the Pythagorean theorem. Look at the general Euclidean metric for a triangle. You have that specific 2ab cosine theta term. Well, in the UATS framework, that term is literal structural exhaust. When the system achieves perfect orthogonality at 90 degrees, that exhaust term evaluates to strictly 0, and we are left with the pure preserved residue, a squared plus b squared equals c squared. It's mind-blowing when you frame it like that. All right, moving on to section 4, the separation energy lemma. So knowing all this, how do we actually detect a runtime error in the prime sequence? While Kulik introduces this rigorous local detector formula. I won't bog you down with the deep calculus today, but the core takeaway is absolute. This local quadratic detector strictly vanishes if, and only if, the lateral displacement, our alpha, is exactly 0. This proves mathematically that any off-seam displacement can be identified with an ironclad local test. Section 5. Nexus RH Operator Architecture. Let's see how we scale this local test up globally. To lock down the entire prime spectrum, the paper outlines a multi-gate architecture, and this is where that software engineering metaphor really shines. Think of gate A as existing at compile time. It runs static certification and Jensen polynomial hyperbolicity checks. But remember, gate A is just a syntax type checker. It validates the code, but it doesn't actually run it. Gate B, on the other hand, is the runtime environment. This is a dynamic, coupled cycle. It takes the highly complex bootstrap-melon arithmetic cascade and links it directly to the analytic mirror of the zeta function. Gate B is what enforces true structural closure. Inside Gate B, the framework relies on a doubled melon bundle carrying a renormalized Bookstop-Volterra operator. Okay, I know that sounds incredibly heavy, but the so what here is surprisingly simple. Proving the Riemann hypothesis requires showing that this round-trip operator totally excludes unity from its spectrum. What does that actually mean for us? It means the operator mathematically forbids any sort of bootstrap of off-critical line effects. Absolutely no illegal lateral wobble states can survive this continuous execution loop. They are completely and utterly annihilated. Finally, Section 6, a universal structural law. We've covered a tremendous amount of ground today, from pure domain architecture to trace class operators. But Kulik's paper leaves us with a profound paradigm shift. It takes the most elusive arithmetic mystery in human history and asks us to view it not as abstract points floating in space, but as the active, executing geometry of a perfectly balanced system. So I'll leave you with this question. If the universe acts as a flawless compiler, constantly annihilating exhaust to maintain equilibrium, can the prime stream ever survive outside that half-offset seam? It really makes you marvel at the idea that ultimate mathematical truth might simply be a matter of perfect runtime safety. Thanks for joining me on this explainer, and keep questioning the code of reality.